Okay, so here are just some problems that I think would be good for this overall Chapter 5 test. I'm going to go pretty quickly, assuming you kind of know what's going on in the class, and show you how I would approach them. Keep in mind there's many ways to do the same problem, so you may have done something different, but as long as we get to the same answer, we should be good. Okay, so let's start here with number 1. This is just the simplify section, so to simplify, you just take it as far as you can with identities. So what I would do is I immediately see something squared and a 1, and I know that there's an identity to replace that, and the tan squared of x plus 1 is actually equal to secant squared. Right off the bat, that numerator equals that. I'm going to recopy my denominator because now look, I have the same thing over itself, so it simplifies to 1. Over here on B, I've got sine of 2x over sine x. Now, sine of 2x, that is a double angle identity. So if you plug in what that's equal to, it should be 2 sine x cosine x. And then I'm going to recopy my denominator. And now, since everything on top is multiplied, it is legal to cancel those out. And your final answer is 2 cosine x. All right, over here, I could, I guess, plug in 1 over sine right now and see what happens, but to me, this screams FOIL. Just the way that it's laid out, and I prefer to do my algebra first before I actually plug in an identity, okay? So I'm going to FOIL this, and whenever you FOIL it all out, this is a difference of squares actually, so it's going to turn into this after you FOIL. And this is an identity, I believe, because let's think about this. I believe that there's an identity that says 1 plus cotangent squared is equal to cosecant squared. And so if that's an identity, if I were to subtract the cosecant squared over here and then move the cotangent squared over there, this should turn into a negative cotangent squared. That is what I am getting. So that's the answer, negative cotangent squared. So just rearrange this identity in as many steps as you need to, and you'll see that it can look like that, and that's what it would turn into. Okay, now we move on to verifying, and verifying is just where you try to make one side look like the other. So I always start on the most complicated side, which to me looks like the left side. And whenever I do this, these aren't the same term. So I would go ahead and start by turning secant into 1 over cosine, and just think of this cosine as being a cosine over 1. And you want to write them as two fractions because now the goal, guys, is to get a common denominator. Okay, now this already has a cosine on the bottom, so I just recopy it. I just turned this into a cosine, which means I need to also multiply the top by cosine, and this is what I'm looking at. Okay, and this is 1 minus, here I'm just recopying. I'm not doing any math other than recopying this as one fraction. Now, 1 minus cosine squared, you should see a lot, and hopefully you're getting trained to where you remember that 1 minus cosine squared is a Pythagorean identity, and you can plug in sine squared for it. And if you feel like you're stuck here, because this is kind of where I am now, let's look back at where I'm headed, okay? So I'm supposed to make this look like this, and it doesn't quite look like that yet, but if you imagine this, sine squared is just being sine times sine over cosine times 1, because it's legal just to say, oh, there's just times a 1 there or something like that, then you can see it. Sine over cosine is tangent, sine over 1 is sine. So we're finished. I know it's kind of got messy here, but whatever. It is what it is. I didn't have enough room. Okay, so that would be for A. For part C, what I would do is if you have your cofunction identities memorized, maybe you do, and you could just use it right off the bat if this is one of them. If this isn't exactly what your cofunction identity is, because sometimes they have minus signs and all that, and like I said, you may not have it memorized. You can definitely do this without a cofunction identity. And the way that you could do it, sorry, I got to make some room, is I am looking at this as a sum and difference. You may have it as u plus v on your formulas, or a plus b, it doesn't really matter, but it's sine of something plus something, and that breaks into the following. Sine of pi over 2 times the cosine of x plus sine of x times the cosine of pi over 2. And so I just plugged in the identity, and now you can do this from the unit circle. The sine of pi over 2 is the y value at pi over 2, which is a 1. So I've got 1 times the cosine of x plus sine of x times, now what's the x value at pi over 2? Well, that's just a 0. So cosine x, it just reduces to that. Beautiful. 2b down here, I think I will also start on the left, and let me see what I can do. Hopefully your teachers have gone over with you this whole idea of a conjugate, because when I look at this denominator, I think, man, I really wish there was like a squared or something that could help me out. And so there's a way to make it a sine squared, and that is to multiply by the conjugate, which just means change the sign in the middle, and then multiply this out and see what happens, okay? So when I multiply this out, I'll draw an arrow, it's going to be the cosine of x times 1 minus sine over, okay, we would have to multiply those out, and when we do it, it's going to be a 1 minus sine squared x, okay? And then I'm still on the denominator. Notice I haven't even multiplied out the numerator yet, and that's actually on purpose, because my hope is that something will cancel, so I want to leave this in factored form. Now 1 minus sine squared x is what? Well, I think it's cosine squared x, right? And now, since I haven't distributed that out, I can cancel one of these cosines, this cosine x, with one of these cosines, and I get 1 minus sine x over cosine x. So you're going to feel stuck, like I kind of feel stuck right now, but then I look back at what am I supposed to get? Like, is it possible to make this look like this? And the answer they want has 2 separate terms with a minus. So how do I make this big fraction 2 separate terms? Well, I just split it up. You've got a cosine on bottom, so just call this 1 over cosine minus sine over cosine. And now, hopefully, what is 1 over cosine? That's a secant. Sine over cosine's a tangent. And I did it. Yay! All right, cool. And letter D, you might want to tune out if you have no interest in getting the bonus problem, or if you're not in pre-AP. This is a toughie. So let me even see if I can do it. I'm sure I can. It just might take a lot of trying here. I'm going to go to a different color. Go ahead and skip in the video if you're not interested. Skip to the next problem. I know this much. 3x, there's no identity for that, so I'm going to split this up into the sine of 2x plus x as my first step, and then I'm going to use the sum and difference identity, kind of like I did on part C. So this is really sine 2x cosine x plus sine x cosine 2x. And that's just what your identity card says. Now, we're trying to head to this, which this only has signs in it. So I need to think to myself, okay, am I ever going to be able to get rid of the cosines? Well, I need to keep going. And to me, the next step is just to plug in for these two. So what is the sine of 2x? Well, that is 2 sine x cosine x. Then I'm going to bring this guy down, plus bring this guy down and recopy, and then cosine 2x. Now for cosine 2x, you have 3 choices if you were to look at your formulas. And there is, you could use any of the 3 that you want. I think I'm going to use one of the 3 that has sine in it. And the reason I'm going to do that is because this identity only has sine in it up here. That's like where we're headed. So the one that I need to use is 1 minus 2 sine squared x, okay? Now what? Now I don't know. Let me just kind of simplify and clean this up. This can be written as 2 sine cosine squared, and then plus, let me distribute this, sine x minus 2 sine cubed x. Okay, this is getting exciting because we're starting to get cubes, kind of like up here. And now, the only thing that bugs me is I still have a cosine in the problem. So is there a way to turn a cosine into a sine? Well, there is if it's squared. So think about your Pythagorean identity. What can I plug in the spot of that box? Well, cosine squared is 1 minus sine squared. Recopy all the rest of this mess. Now, distribute, distribute. So I have 2 sine x minus 2 sine cubed x plus sine x minus 2 sine cubed x. And I'm out of room, so I really hope all this is going to combine now. Do we have any like terms? Yes, these are like terms, and what do they make? They make a negative 4 sine cubed x, and then I have this one and this one. These are like terms, and I'm done. Hallelujah. All right. So, fun problem right there. All right, now we move to number 3. And on number 3, we're solving. And in a solve, remember you're giving angle answers. So, on this one, I always look at, on the given interval. So this one wants me to give my answer on 1 revolution of the circle, and they want me to give my answer using degrees, and I know that because they gave me degrees here. So the goal here is always to isolate the trig function if possible and solve for it. So I'm going to start by moving that 1 to the other side, and then dividing by the 2 that's in the front. So just by a little bit of algebra and rearranging, you should get to this point. And if you get stuck here, just keep in mind, if you ever need to get a squared off something, you just need to take the square root. And when you take a square root of something, don't forget your plus or minus. Now, plus or minus the square root of 1/2, you might be thinking, but that's not on the unit circle. But it is. The square root of 1 is 1. The square root of 2 is this. And guess what, guys? When you rationalize this, it turns into that. And this is most definitely on the circle. It happens at all of the 45 degrees. So I'm just going around the circle. Ew, what's 180 plus 45? 225. And then 270, is that 315? Okay, so I think those are the 4 we're looking after, but that's going to be your answer. I'll go ahead and put x equals just to be legit. Okay, now I'll move down to part B. Okay, here you got to be careful. You may be tempted to factor or cancel something, but you really can't, because that's got a 2 and that doesn't. So this screams to me an identity. So this is a double angle identity. So if you've covered those, you can do this problem. If you haven't covered double angle identities yet, I guess you have to skip this one as well. So turn that into its identity and then recopy the rest. Okay. Now we can factor, guys, because this term and this term both have a sine in them. So I'm going to yank that sine x out to the front, and when I take it out of this term, it leaves behind a 2 cosine. When I take it out of itself, there needs to be a 1 there. And now you just take each parenthesis and set it equal to 0. So where does the sine equal 0 on the unit circle? That would be a y value of 0. So this would be at 0, pi, 2 pi, all of those, okay, dot, dot, dot. And then this one over here, this would be cosine x equals a positive 1/2. So the x value being a positive 1/2, that happens at all the 60 degrees. So like pi over 3. But then if it has to be positive, be careful, because it can't be quadrant 2 or 3, so it needs to be 5 pi over 3. And then we'd have to go all the way back around the circle to this and this again. So the reason I listed a few out is because when you see this, it's kind of scary. You're supposed to write your answer almost as an equation. So for this one, it's like x can be all of these, right? Well, let's look at these. All of these answers are values of pi, right? Like 0 plus pi, plus, if we just kept adding pi, we would see every single time that the sign was 0. So I could just say, okay, so x can be pi n. So basically any multiple of pi is the answer. And that's how I would write it, as an equation. This one is a little different because it's here, but then it jumps way across the circle, and it's this one, and then all of those coterminal angles. So what I would do is list both of these out since there's no pattern between those two, and then I would just put plus or minus 2 pi in at the back of that, because you can add an entire revolution to make that happen, okay, and get all of the coterminals. All right, so now we jump over to C. So for C, we're back to 1 revolution of the circle, and I'm going to do what I told you guys earlier. I'm just going to get the tangent by itself, and you might be looking at this thinking, well, I don't know what that is. Well, if you rationalize that, you're going to get negative root 3 over 3, which that should look familiar. In fact, in previous videos, I told you I've already memorized these 3 tangents. If it's pi over 6, I know it's a root 3 over 3. If it's pi over 4, it's 1. If it's pi over 3, it's root 3. And if you've memorized those 3, then as soon as you see this answer, it's not scary, because it's going to be something over 6, okay? Now you just got to figure out what over 6, okay? So what quadrant would tangent be negative? Well, it'll be negative in this quadrant, and it'll be negative in this quadrant. So what are the over 6 values? Well, this one is 5 pi over 6, and that one is 11 pi over 6. So those are my 2 answers. And the last one, part D, looks fun again. So we're still on 1 unit of the circle, 1 revolution of the circle. I would definitely, when I see these, I don't like that they're different words, so I would start by plugging in the identity for that one. And that way I've turned everything into a sign. And then you can sort of like bring this one over and set this whole thing equal to 0. And what that does is it's going to make it look like a quadratic. So this is going to be, I'm just going to kind of reorder how these are. Negative sine squared x minus 2 sine x, because I'm bringing that to the other side. And then what's 1 minus 2? 1 minus 2 is negative 1. Okay, and we're going to factor that. But before I factor it, let me change all the signs to make it easier. Yay! Okay. And now when we factor, I'm going to get a sine x in the front, a sine x in the front. Okay, how do we do that? How about plus 1? Does that work? If we FOIL that out, will it equal this? Yes, it will. So our answer is when sine x is equal to negative 1. When does the y value equal negative 1? At 3 pi over 2. So this is one of those rare ones that it actually only had 1 answer. Usually they have all kinds of answers. Okay. So, yay, we're down to the fun stuff. So this is where you just evaluate and get exact answers. So for cosine of 105, what you're trying to do, and it says to use the sum and difference identity, so I need to think of 2 angles that I could add together that make 105, but both angles have to be unit circle angles that I've already memorized. So I'm going to choose 60 plus 45. You may have chosen something else. It really doesn't matter, as long as it made 105. Now I plug in the identity that goes with the cosine. I'm not talking because I'm just copying that identity. Great. Once you do that, you just roll into the unit circle values. So what is the cosine of 60? Well, it is 1/2. What is the cosine of 45? Root 2 over 2 minus sine of 60 is root 3 over 2. And sine of 45 is root 2 over 2. So lots of unit circle stuff. And then you just multiply radicals, top times top, bottom times bottom, top times top, bottom times bottom. They already have a common denominator, so you just recopy these 2 guys. Perfect. And I know it's not a pretty answer, but it is your answer. All right, part B is the same thing. It gives us a funky angle, or the sine of an angle to find, and it tells us to use a half angle identity now. So now I have to think the sine of some mystery angle over 2, and then I need to break into my identity. So what is the mystery angle that I could put up top here that when I divide it by 2, it would equal pi over 12? This is a good question. Is it pi over 6? I think so. I think that works, because if I take pi over 6 and divide it by 2, I get pi over 12. So that's the key to these, is you got to figure out what that angle's going to be, because then when you come over here to this identity, you can just straight up plug this in with the pi over 6. Now, the other thing is you have to know whether to use plus or minus. Now, I know to use positive, and the reason I'm using positive is because the sign, these are in the first quadrant, and the sign in the first quadrant is positive. So this should be my answer, and I could just work it all out. So this will just be 1 minus root 3 over 2 over 2, which is the square root of, what would that be? 2 minus root 3 over 4, which then breaks up like this. Okay, so you've probably done a few of these in class, and you know the algebra that was just done here. I just did common denominators, combining my denominator. I did all that, and if you need further help, let me know, and we can talk through how I did that. But I was just doing some algebra to break down that number. And that's your answer. Okay. C, the cosine of 2b given sine of b and blah, blah, blah. Okay, so on these, you've just got to think about, this is there to tell you what quadrant you're in. So between pi and 3 pi over 2 means that you are in the third quadrant. So what I would do is just draw like a random line, just so that I could have my little right triangle, okay? And this is just like the last chapter. Make a little right triangle, and we know that the sine is 3 over 5, or negative 3 over 5, which means that the opposite is 3, and the hypotenuse is 5, and the negative is going to go on the 3, because that's my y value, right? And the y value is negative in the third quadrant. I also know this, that once I solve for the fourth side of the triangle, which by the way, this is a 3, 4, 5 triangle, once I'm like, oh yeah, that's a 4, it's actually a negative 4 because you're in the third quadrant. Okay, now that you know all three sides of your triangle and who's positive and who's negative, now we're going to figure out what this means. Okay, well, cosine of 2b, there's 3 identities that go with this. There's 3 different choices. So you can use, really, it really doesn't matter. The first one that popped into my head was 2 cosine squared minus 1. So I'm going to use that. So there's my 2. And I need to plug in my ratio for cosine b. Cosine is adjacent over hypotenuse, so negative 4/5 will go there, and then minus 1. So I'm going to square it first. That's 16 over 25. Then I'm going to multiply by the 2, so it's 32 over 25 minus 1. Then I'm going to get a common denominator. So I'm getting 7 over 25 as my final answer. Yay! Okay, part D, this is going to be the same thing as the one up there. It's just going to be the challenge problem, meaning it's a little bit harder. So this is going to be worth a lot of points on a test, or maybe even a bonus. So it's going to be the same thing, except you've got 2 different pictures to draw. I'm going to put A here, and B. And the reason I know it's A and B is because those are the 2 variables given here, and there's 2 different criteria. So A is going to be the triangle that goes in this quadrant, which this quadrant is from 3 pi over 2 to 2 pi. So on this one, this is where I'm going to draw my little right triangle. Okay, and the cosine is 5 over 12, so it's 5 for the adjacent, 12 for the hypotenuse. Now, do you know what the third leg is going to be? I think it's going to be, I don't know. We're going to have to figure that out. It's the square root of something. 144 minus 25 equals the b squared. So what's that going to be? I think it's like 119. Oh, what a pretty problem. Okay, so that's going to go there. Now for the b, that's in this quadrant. It's from pi over 2 to pi, so I'm going to draw my b in this quadrant, drop it down to make the right triangle. And on this one, I know that the sine is 3 over 4, which means that the opposite is 3, and the hypotenuse is 4. And so if I can find my other side, that would be, what would that be? 16, that'd be the square root of 7. So this is going to be an ugly, ugly problem already, I've decided. Okay, but now that we've found all of our sides, does anything need to be negative first of all? Well, on this one needs to be negative because look at what quadrant we're in. The x is negative. In this one, the y is negative. So I need negatives on both of those. And now we're going to find sine of a plus b. Alright, so the identity for sine of something plus something is sine a cosine b plus sine b cosine a. So now I just look at my picture of my triangles and figure it out. So for the sine of a, I'm going to do opposite over adjacent of this picture. Okay, so opposite, not opposite over adjacent, opposite over hypotenuse, sorry. Awesome. And then the cosine of b is look at this picture and do adjacent over hypotenuse. Okay. Is that a 4? Good. Plus the sine of b, 3/4, the cosine of a, 5/12. And then we're going to math that out. Gross. Okay, so the denominator I can do, that's a 48. Yay. And then negative times a negative is a positive. This is going to be the square root of idk. Let me multiply this out to the side. That would be a, what's 7 plus 6? 13? 833. Gross. Okay. Plus, over here, 15 over 48. So the answer is root 833 plus 15 over 48. And that's why it would be a bonus or a really high point problem. Lots to do, lots of steps, lots of ugly numbers. Everybody should be able to do something like these though, okay? On a problem like this, you're just working backwards. So they're giving you the expanded identity and you work back to the prettier form. So I already can see if it's a cosine cosine plus sine sine, that's the one that goes with cosine of a minus b. And that's just if you haven't memorized. And so in this case, the a is 10 and the b is 45. So this is the cosine of negative 35. And that's how I would leave it, just like that. Because that's not on the circle, so I can't find it. Over here, a tangent minus a tangent over a 1 plus tan tan, okay? That one's going to turn back into, which one is that? I think that's the tangent of a minus b. So it's going to be the tangent of 5 minus 60, which is what? Which one is this? Did I do this right? Let me make sure I use the right identity there real quick. Yeah, I think I did that right. I sometimes get the tangent, sum and difference, and double angle confused, but I think I'm using the right one here. Okay, and then down here we've got sine of 11 over 1 plus cosine of 11. Okay, and if you look through your identities, this one's kind of trickier. This one leads back to the tangent of x over 2. So in this case, the x is 11, so you would be doing the tangent of 11 over 2, and then you would just stop right there. Over here, this looks like another half angle. So if it's a half angle, you just have to decide is it sine or cosine. When there's a minus there, that's the one that goes with sine. And in this case, the x is a 100. So sine of 50. And that's how you would do these problems. And if I messed any up because I had the identity wrong, please let me know, because I am going from memory and not staring at an identity sheet. But hopefully we did them all right. But like I said, feel free to let me know if I messed something up. All right, good luck, guys.